Okay, YouTube, in our last video, we had explored the different types of sampling methods we use when collecting data, say for an experiment. And so what we want to do in this video is look at kind of biases, what we mean by biases, and how they kind of can affect your sample. So the first thing we're going to start with is basically the definition of what we mean by a mathematical bias in your sample. We'd say that a bias is an error that results in a misrepresentation of the population. That is to say, if we're going to look at the height of the entire population. So we say population height, okay? And what we do is we go and we look at, and maybe we say just like older than 20 years, okay? Well, what we do is we go only look at NBA players, okay? NBA players over 20 years in our sample. We're going to get a biased sample because what we're doing is we're over-representing a group of people who are already, kind of tall themselves. And so they have a bias. And so we say a bias, again, is an error that results in a misrepresentation of the population. If we have a biased sample, then we say that this is a sample that certainly does over-represent, or we could under-represent only part of the population. So what we're looking to do is kind of look at how we could get as much as possible an unbiased sample. And an unbiased sample, as we look at this, we say is representative of the population that you want information about. And so if we want information about 20-year-olds or older and their height, then we want to get a really unbiased sample here that would represent our population very well. So our goal in studying sampling methods basically will be for us to minimize the amount of bias we have in our statistical sample. But the way we look at bias is also this: minimize the amount of error that we have when reporting about the population based upon a subpopulation or a subgroup of the population. So we say when a sample is biased, the data, they tend to be invalid. So that's why we prefer to use a random sample. And of course, our random sampling techniques were these that we had listed here. And so recognizing bias, that's what we're going to look at in this video. How do you recognize that there is bias? And so identifying, here it says identify the type of sample and then explain why the sample is biased. Let's go ahead and start with a type of sample. In letter A, it says that a news organization asks its viewers to participate in an online poll about bullying. And so when we say, I'm asking you to participate, what kind of a sample are we discussing here? I mean, is this self-selected, systematic, stratified, cluster, convenience? I would say that most of all it's probably self-selected because we're only going to get data from those who actually chose to respond. So first things first, this is self-selected. Now in terms of why self-selected things may be biased, and I'm talking about letter A here, because if it says that a news organization asks its viewers to participate in an online poll about bullying, we're only getting results from those people who chose to respond. And so let's put it this way. I know it sounds kind of harsh, but maybe the type of person who would take the time to respond about bullying may be the type of person who feels really strongly about bullying, or maybe doesn't feel very strongly at all. And maybe those things are connected, but what you're going to see is you're not going to get an accurate picture about what people feel about bullying unless you also ask the people who didn't respond, which we don't have that data. So we're only getting results here. And I suppose, I could type this in because I'm a much better typer than I am a hand writer. So we're going to look at this here. We say, why would this be flawed? We say, only getting results from those who took the time to respond to the survey. And so that would be a biased thing, maybe. And that's what I want to do, is just call into question that may present invalid results. In letter B here, it says a computer science teacher who wants to know how students at a school most often access the internet. The teacher asked students in one of the computer science classes. And so since we're kind of hitting up an entire computer science class, and that's already kind of a bundled group here, I suppose, trying to flip back over to our sampling methods, but I think because my mouse here is on typing, we can see that this is a cluster of people. It's already been predetermined. So let's go ahead and recognize that this is a cluster. This is a cluster sample. And that if we were to say, why would this be biased? We're not getting results from students in any of the other computer science classes. And so we want to not miss out on those people. Perhaps what we could do to make this better then would be to do a stratified sample, and that is to say choose a certain amount of students from each class if they wanted to get a more random sample. So speaking of random samples, there is one item that I do want to look at on this video, and the simple fact is we have a calculator function. It's basically, it chooses a random integer for you. And let's take a look at this random number generator. Where we're going to find it is essentially in our math menu. And in our math menu, what we're going to do is over at the top here on a TI-83 or 84, there's this probability menu. So as we scroll over here, you're going to notice that random is at the top, but we want random integer because we want a random whole number from 1 to 246. So you see this basically this command here. What we're going to do is we're going to scroll down here. We're going to type in 1. So starting at 1 and then up to 246, we want a random integer from here to here. So if we were to hit this, basically it says 71. Okay, so we would say maybe select the 71st person and maybe not put that back into the population. We say now next we would select the 227th person. We would just keep doing this, and if we wanted 50 seniors, I suppose we could do this 50 times. And so basically, one way to do this, I suppose if we type this out here, is we can assign a number to everyone in the population of 246 seniors, and then draw the numbers using a lottery system. Which is not actually one of the ones that was presenting on our other page there, but the lottery system there, that would be a completely random sample if we do a lottery system. And so we could select the first 50 random numbers using a graphing utility. I suppose we could do it that way, graphing utility as we just did, or other computer device, or I suppose select out of a hat, which isn't feasible a lot of times, so that's why we use a random number generator. And so here's what I want you to look at here. This next example on this other page here. What I want you to do is kind of the same thing here. Let's take a look at these. Pause the video, read through them, and try to select what type of sample it is and identify why it might be biased. Okay. When you're ready to see the solutions, go ahead and unpause the video. Number 3, of course, this is the manager of a concert hall wants to know how often people in the community attend concerts. So the manager asked 45 people standing in line for a rock concert how many concerts they attend per year. What we want to do is identify the type of sample. And so in terms of identifying what kind of a sample, we'd say 45 people standing in line. That's kind of convenient there. What this is a convenience sample here. And so in terms of why this might be biased, why might this be biased in terms of asking people who are already in line for a concert, how many concerts you go to a year? We would say, maybe people in line for a concert maybe are more likely to have attended many concerts, in the year. And so you're going to get a bias sample there. Now, on number 4 here, it says in example 3, what's another method we could use to generate a random sample of 50 students from our previous example? Explain why your sampling method is random. Well, looking back at our sampling methods here, I suppose we could ask people, but that's not going to be very unbiased. Also, just selecting students who are standing around you, 50 seniors out of that 246 seniors, not as random. So we talk about, could we layer them, could we bunch them, or could we look at a systematic? And I would say that the systematic approach is probably the best possible approach. So we can use a systematic approach. And the way we'll, systematic sample, the way we'll do this is start by randomly, I would say, selecting a number from the population. We could do that on a calculator. Then from there, choose every nth person. Now we could figure out this nth person, and the way we could do this is we could basically say, well, with the calculator we have 246 students. If we were to split that up into 50 equal size groups divided by 50, we would say that there'd be about 4 students in every group. And so to be somewhat inaccurate here, we could say choose every maybe 4th person or every 5th person, and we would get a good idea. Cheers.